So, Algebra 1, this is 5.2. We are going to be solving inequalities by multiplying and dividing today. Last lesson was on adding and subtracting. What this comes down to, guys, all the same rules that we've been using for solving equations, and hence, in this case, one-step equations, you still can do here. And so, last time you could add, you could subtract, it doesn't change the inequality. Today, we're going to multiply and divide. It doesn't change as well. But there is going to be a small little caveat that we have to worry about. Now, there's a big box here, and in this box we have the words, we have the symbols, and then we have some examples. To me, the most important part of all of this is just the words right now, because I'll explain, and we'll kind of show a little example on the side to kind of make this happen. So to me, it's these two right here that kind of should be written down. The rest of it should make sense. I think some of the rest of this, if we tried copying down with all the different variables, it could get a little confusing because there's just a lot of stuff going on. So, the top one says that if both sides of an inequality are true, so if the inequality is true, then multiplying by a positive number to both sides results in an inequality that is also true. Now think about this. We used this last time. That last time you could say, hey, I have more cookies than the person next to me. If I multiplied each of you by 2, so now you have twice the amount of cookies, your person next to you has twice the amount of cookies, you still have more cookies than they do. Because if you double a number that's bigger, it's bigger than a different number that's smaller, right? So 5 versus 3. 5 doubled is 10. 3 doubled is 6. 10 is bigger than 6. Still true. Now, the second layer here now talks about there's a small change. That it says if both sides of an inequality are still true, and you multiply both sides by a negative number, the direction of the inequality sign is reversed or flipped, and then it makes the resulting inequality true. So it's not just enough to multiply both sides by the negative number. The inequality sign in the middle flips. So, an example, if you had 5 and we say 5 is bigger than 3, I think everybody would have to agree with that. If I come through and multiply both sides by, say, negative 2 now, negative 2 times 5 is negative 10, and 3 times negative 2 is negative 6. Which one of those two are bigger? Negative 10 or negative 6? Negative 6 is actually a bigger number. So therefore, the alligator mouth should be turned. Look, it's flipped. It's reversed. If I multiply by a positive, I don't need to flip. I don't flip. If I multiply by a negative, it reverses or flips. So on the bottom, in black, highlighted kind of in a way, bold, this is the important takeaway from multiplication. If you blank by a negative number, you need to blank the inequality symbol. What are the blanks? If you blank by a negative number, multiply by a negative number, you need to, what happens? Flip or reverse the inequality symbol. I'll say it one more time. If you multiply by a negative number, you need to flip the inequality symbol. So you're going to flip the inequality symbol when you multiply by a negative. And so now let's do some examples. I have 1/5 m is greater than or equal to negative 3. How am I going to get m by itself? How do I get rid of a 1/5? Multiply by the reciprocal of what? So I'm going to multiply by the reciprocal of 1/5, which is 5 over 1, or just even 5. So I come up here, multiply by 5, multiply by 5. What's 5 times 1/5? That's not nothing. It's 1. So it becomes, they're gone, right? M. Negative 15, because 5 times negative 3. What's the symbol? Is it supposed to be a greater than, equal to, or a less than or equal to? Do I flip it? Stays the same. This is not a negative number. Even though there is a negative in it, I did not multiply by a negative. I want you guys to also understand that we are going to be able to graph these. So if I had to graph this, I make my number line. What number do I use? Negative 15. And then I ask myself, is this open or closed? It's a closed dot because it is equal to. What point do I want to check? 0. 0 on the left or the right? It's on the right. So over here. Is 0 greater than or equal to negative 15? Bless you. Is that true? Yes. So I'm going to shade to the right. Now, again, it was brought up last hour that, hey, this little arrow right here is pointing to the right. So guess what side I shaded on? The right. I talked about that last time. This is not necessarily always true, because I think everybody should recognize that negative 15 in m, but now it's negative 15 is less than or equal to m. And according to that same exact rule, here, I should be shading to the left. The rule only works if your variable's first. So do not think that you can just shade the way it's pointing. Check a point and shade. So we could solve it, which we did. We can graph it. Can you guys give me the set notation? Remember what set notation was? Set notation had the brackets. So it's a bracket, m, such that, which is a straight line. And then, which one are you going to choose? You're going to choose the m is greater than or equal to negative 15, or negative 15 is less than or equal to m? Yeah, the top one. M is greater than or equal to negative 15. And your bracket. Always put your variable first. Okay? I want you guys to be able to do this, and that. So solve it, graph it, and put it in set notation. Different times you're asked for different things. I'll give you guys a minute here or so. Do part B. Negative n over 3 is less than or equal to 8. So, what's the idea here? What do we want to do? What do you think we can do? How do I get rid of a divide by 3? Multiply by 3, right? Now, there's a negative attached to it. I like to do this at once. So I'm not just going to multiply by 3. I'm also going to get rid of the negative, but by multiplying both sides by negative 3. 8 times negative 3 is negative 24. The negative 3's cancel, leaving me with n. Which way does the sign supposed to go? Is it stay or switch? It switches. So n is greater than or equal to negative 24. I'll save you guys a little bit of time. In your homework, you're going to have to do the graphing and set notation. We don't have to do it right now, unless someone wants me to. Should we practice the skill still, or you guys think you got it? Think we got it? Okay. So, does everybody understand how I got n is greater than or equal to negative 24?
Yes.
So, more notes. Second set of notes. It was asked already today. Well, what happens if I divide instead? Well, here they are. So again, just like the first box, this one is the division properties. And we got the words, the symbols, and the examples. Again, we'll do our own examples of the second level here. The first level here says that if you divide both sides of a true inequality by a positive number, you leave everything alone, you just divide it out, solve it. Still true. But in the second layer, that if you divide both sides by a negative, to make it true, you have to reverse the inequality symbol. So really the important takeaway again on the bottom, if you now divide by a negative number, you need to flip the inequality symbol. And at the very bottom, wait a minute, don't you say that both times? Flip the inequality symbol? And they both had what in common? Negative number. Therefore, anytime you multiply or divide by a negative number using inequalities, you need to flip the inequality symbol. You need to flip the inequality. That's the biggest takeaway. You flip the inequality, guys, when you multiply or divide by a negative number. If it's not negative when you're dividing it by or multiplying it by, then you leave it alone. Okay, so the last three examples. I want you to solve by dividing. Now, when you guys get to your homework, it's not going to say solve by dividing, solve by multiplying. You need to recognize. Okay? So, A, 8p is less than 58. How do we get p by itself? Divide by 8 to both sides. 8 is positive. Do I change the sign? No. 8 divided by 8 is 1, so it's gone. Is less than 58 over 8. Leave it as an improper fraction, guys, but make sure you simplify it or reduce the fraction. Is 58 and 8, they're both what kind of numbers?
Positive.
They're positive and they're even. So that means if they're even numbers, they're both divisible by 2. What is 58 divided by 2? 29. And 8 divided by 2 is? It's 4. 29 is a prime number, I do believe, so 29 over 4. If you feel inclined, you have to. You take 29 divided by 4 and you get 7 and 1/4, or 7.25. I don't want mixed fractions. I'm okay with the improper fractions. Larger top than the bottom. What kind of what kind of dot will this be on a number line? Open. Okay. B. Solve for R. This one's kind of nice. What do I do? Divide by 6. What is negative 42 divided by 6? Negative 7. There's an R. What's the sign going to be, or the symbol? Greater than or less than? Still greater than because We're not dividing by a negative, so therefore don't flip it. Again, open dot. And the last one, I'll give you a minute to try that out. So what's the next step on here to get h by itself? Divide by? Divide by negative 12. Are bells going off in your head right now? We're now dividing by negative, so what's going to happen? The sign flips, so h is less than negative 15/12. The symbol flips. Top and bottom of this fraction are divisible by what? Three. 15 divided by 3? 5. 12 divided by 3? 4. And there's your answer. Open dot. Any questions? Homework on 5.2, page 299, 12 through 23. Have a great day.